And we wrote down here already, mz is going to be what? Compression. When it's going to be compression, just put a minus sign. Now you look at my. Okay, this is going to be my, and my both are also going to be what? Compression. So both are now going to be in the what? Both are now going to be in the minus. Easy peasy, sneezy, limey, squeezy, or whatever. Okay, so now you just put in minus mz is equal to 9397 divided by izz multiplied by y, right, minus by my divided by iyy multiplied by z, which is equal to 4. So this will be equal to 9397 divided by 88 is equal to minus 106.784. And then minus by 3420 times 4 divided by 64, minus 2137. Okay, 213.75. So this will be equal to 106.784 minus 213.75 is equal to minus 106.784, 213.75 minus 320.534. This is in pound in, so pounds per square in PSI. Okay, so the analysis is already what? It's already done, right? You don't need to worry about positive moment, negative moment. You don't need to worry about Y positive, Z negative. No need. Okay, you just focus on your moment vector. Okay, so now next we look at point B. Okay, point B, again, if we look at point B, Y distance is also equal to 1 inch relative to the center. Okay, and the Z, same as point A, is also equal to 4 inches. Okay, so now you write down as stress X. Okay, so this is stress X at point A. Sorry, got too excited. Okay, so now this is stress X at point B now. So you just write mz over izz multiplied by y, my over iyy multiplied by z. Okay, so if you look at mz, right, mz at point B written down here is what? Tensile, right? So this is positive. And then my, right, my at point B, you have written it is compression. Just put a minus sign down. So this is equal to plus 9397 multiplied by 1 divided by 88. Now this is minus 3420. Z is 4. And divide by what? Divide by 64. So this will be equal to positive 106.784 minus by 213.75. Okay. So 106.784 minus 213.75. So this is equal to minus 106.966 PSI. Okay, 106.166 PSI. So the last point that we're going to find is at point D. Okay, at point D, Y is equal, so the Y distance from point D, right? So the Y distance, the vertical distance is 3 plus 1 is equal to 4 inches. But the Z is exactly at the neutral axis is equal to 0. Okay, so we will have, so next we will find stress X. Okay, we are going to find stress X. At point D is equal, again, write down mz over izz multiplied by y, my over iyy multiplied by z. Okay, and we know that this is equal to what? equal to 0 because Z is equal to 0. Then you look at MZ. Okay, so moment about Z. Okay, moment about Z at point D, moment about Z, we also know that it's tensile because it's at the tail end of the moment vector. So it's going to be positive. Okay, so this will be equal to M, which is 9397. Y is 4 and divide by 88. Okay, so 9397 times 4 divided by 88 is equal to 427 positive 427.136 psi. Okay, so you can see, right, is not that difficult, right? By the most important thing is this. The most important thing is this. The most important thing is this moment. This is the key. Okay. Once you got that, okay, you can now you need to know how to find IZZ, IYY, when to when you can find the centroid by observation when you need to use the formula. Okay, that this is critical because while grading your term test, we discovered that some students, okay, don't know when to find the centroid, when no need to find the centroid through observation. Okay, that's what we discovered. Now, this is unsymmetrical bending. Okay, and I think I'm going to simplify the analysis. Okay, why is it unsymmetrical bending? Okay, this I just show you value, but while doing it, I realized that it might not be the best example. But I'm going to do something similar. Okay, I'm going to do something similar. Okay, so if we will have to again, okay, I'm going to highlight about unsymmetrical, or I'm going to go into centric, unsymmetrical, yeah, we're going to look at centric, unsymmetrical bending. So now if we have our structure looking like this again, okay, then we have our axis. Oh, I should not use this color. We will have our axis. So this is Z. And then this is Y. I'm going to do something slightly different now. Okay, so this is Y. Okay, and then I'm going to again call this point alpha, beta, and then I'm going to have this as I and J. And now the moment vector is in this direction. Okay, now the moment is in this direction, right? So I'm just going to call this angle as our beta angle, for example. Okay, so from here we know that this will be our MZ. Wrong color. You know, from here, this is our MZ. And then the next one, this will be our MY. right? This is our my. Okay. So again, we go to our, okay. So we know that this is our mz, sorry, our my. So I'm going to copy. I'm going to come over here. I'm going to paste as an image. Okay. And then I'm just going to do this, right? So you know my at the bottom is going to induce on the left hand side, on the right hand side is going to be tensile. My on the right hand side is going to be compression. Okay. And then we are going to go into the next one, which is this diagram over here. This is not so good. It's okay. Pardon me. I'm going to copy. And I'm going to go over here. No, I need more. Okay. I'm going to paste. I'm going to get rid of this. And I'm going to string it. And this is relative to our MZ direction, right? So MZ, this is tensile, anything on top. And MZ, this is compression, or COMP. And by observation, okay, by observation, IZZ is greater than IYY. Why that is the case, right? Wait, IZZ. Why that's the case? Because if we were to have, why make that observation? If this distance is A and this distance is B, right? We know that the fact that B is greater than A. So when we write out IZZ, okay, IZZ is A B cubed over 12. And this is greater than IYY, which is equal to B, right? So YY, so the width is B, A cubed over 12. Okay, makes sense, right? Okay, right. So now we are going to, I want to see what is the best. Okay, we are going to find, okay, we are going to find stress X, okay, about point alpha. Okay, so we know that this is equal to mz over izz multiplied by y, and my over iyy multiplied by z. Okay, so at point alpha, right, point alpha, mz is going to be what? Tension plus. Okay, and my, so we look at my over here at alpha, right, is going to be, alpha is on this side, is going to be compression, negative. Okay, so if I'm just going to write this out, so this is equal to mz over by izz, right, positive. So y, right, so the y distance is b over 2, right, minus by mz over izz, oh sorry, my over iyy, right? And then this is in z, so z direction is left and right, so it's a divided by 2. Okay, so this is for alpha. If I do stress x for beta, okay, so same thing, mz over izz multiplied by y, my over iyy multiplied by z. Okay, so now we are going to focus at point beta. Mz for point beta is positive. Okay, my, right? Beta, so beta is on the right hand side and is going to be in tensor. Both are positive. So when you write this out, this is equal to positive mz over izz, right? B over 2 plus by my over iyy a over 2. So what we realize comparing these two, right? Stress x at point